Good morning, student. Today, in chapter Lines and Angles, we will study about the adjacent angle, linear pair of angles, vertically opposite angles, and axiom 6.1. So, first of all, I start about the adjacent angle. What do you mean by adjacent angle? As you can see here, that is the in figure ABC is a large angle, and we have studied about adjacent angle in earlier classes. The two angles are adjacent if they have common vertices. If they have common vertices, that is here vertex B is common and a common arm, and their non-arms are different side of the common arms. So here common arm is BD. For adjacent angle ABD and DBC, you can see BD is a BD is adjacent angle. That is the adjacent line. Here you can see here adjacent line. This is a common line. BD is a common line, and two arms AB and BC are other side of the common arm. So two angles are adjacent if they have a common vertices, a common arm, and their common non-common arms are different side of a common arm. In figure you can see ABD and DBC are adjacent angle, and ray BD is common arm and point B is common vertices. Ray AB and ray BC are non-common arms. So two non-common arms you can see here. So angle, as you can see here, as angle, as you can see, that is a angle ABC equal to ABD plus DBC. So note ABC and ADB are not adjacent angle. Why? Because they are non-common arm. BD, non-common arm, BD and BC lies on the same side of a common arm. So non-common arms should be both sides of common arm. Non-common arm AB and BC. Non-common arm must be two opposite direction of a common arm. Then it will be a adjacent angle. Now next topic. Here linear pair. As you can see, linear pair. If a non-common arm AB or BA and BC form a line, non-common arm, एक line बना दे. When a non-common arms form a line, then it will be a linear pair angle. So here angle ABD and DBC are called linear pair angle. Here you can see that is the DB. DB is a ray standing on a line, and two adjacent angle ABD and DBC are two adjacent angles, and they form linear pair. When linear pair forms when A, B and BC are two opposite directions. Now next, vertically opposite angles. You know the vertically opposite and what are the vertically opposite angles. So here when two lines AB and CD intersect each other, say at point O, then they form two vertically opposite angles. One pair is AOD and BOC, other one AOC and DOB. So these two are vertically opposite angles. Now next point is pair of angles. We have learned about the definitions of some of pair of the angles. such as complementary angle, supplementary angle, adjacent angle, linear pair angles. And now let us find out the relations between the angle formed when a ray is stand on a line. So yeah, as you can see in the figure, so here a line AB and the ray OC. You can see OC. What are the angle formed at the point O? So angle AOC and BOC, and angle AOB. So we can write angle AOC plus BOC equal to AOB because they are adjacent angle. AOC plus BOC equal to AOB because they are adjacent angle. So sum of two adjacent angle, as they are two adjacent angle, how they are adjacent angle, because OC is a common arm, and the AO and OB are in opposite side of the common arm, so they forms the adjacent angle. So we can refer the sections as 6.2, that is the angle. What is the measure of angle AOB? So it will be AOB, that is 180 degree, as it is from a line, so it is 180 degree. So from 1 and 2 we can say that AOC plus BOC equal to 180 degree, and from above discussion we can state the following axiom. That is axiom. What is the axiom? That is the truth that is given by Euclid's. You can see, if a ray is stand on a line, then sum of two adjacent angles so form is 180 degree. Recall, when sum of two adjacent angle is 180 degree, then they are called the linear pair. So if a ray is stand on a line, the line is a straight line, and then a straight line must have the that is the sum of angle. Here you can see a straight line, its angle must be 180 degree. So here you can see that is in figure 3. So 180 degree. So if a ray is stand on a line, then sum of two adjacent angle is 100 degree. Recall the then axiom 1 we can say from this: if two adjacent angle, here a point A, if two adjacent angle 180 degree, then ray stand on the line, the common arm form a line. So common arm, the two different common arm, if a sum of two adjacent angle is 180 degree, then the ray stand on a line, a ray to stand on a line. If because sum of two adjacent angle equal to 180 degree, so a ray must stand on a line. So a ray stand on a line because a ray forms two adjacent angle whose sum is 180 degree. So that is the, it will be a line. If a ray stand, that is the, if the sum of two adjacent angle is 180 degree, then a ray stand on the line. Or if the first axiom, 6.1 axiom, is that if ray stand on the line, then sum of two adjacent angle form is 180 degree. If a ray stand on a line, it is given a line. So if a ray stand on a line, the sum of two adjacent angle is 180 degree, as we have seen in previous sections, that is we have studied in previous topic. Now we will study about the, if sum of two adjacent angle is 180 degree, then ray stand on the line, and the that is the, you can see here what these are the two figure, two adjacent angle are not 180 degree in figure 1, figure 2, in figure 4, but in figure 3 it is sum of two adjacent angle equal to 180 degree. So a line AB is a line and whose measure is 180 degree, so OC stand on the line. This is axiom. Now we can say the second axiom is that if sum of two adjacent angle is 180 degree, then the non-common arm form a line. Non-common form are angle form a line. So this is the second axiom. We can say that first one is that first axiom, you can see that first axiom, if a ray stand on a line, then sum of two adjacent angle is form is 180 degree. And second one is same truth, we have reversed the question ones, that is axiom 1, that is if the sum of two adjacent angle is 180 degree, then a ray stand on the line. So sum of two adjacent angle is 180 degree, then a non-common arm form a line. This one is the second axiom. Now we have to prove that theorem, that is 6.1 theorem. If two lines intersect each other, then vertically opposite angles are equal. Here two lines AB and CD we have drawn. I have drawn. And now you can see in question number 1, that is angle AOC and BOD, opposite, vertically opposite angles are AOC and BOD, and AOD and BOC, AOD and BOC. Now we need to prove that angle AOC equal to BOD and AOD equal to BOC. So how we will prove? Now ray AO stand on CD. You can see AO stand on CD. AO stand on CD. You can see here AO stand on CD. Now next one is that so therefore AOC angle AOC plus AOD equal to 180 degree. As a ray stand on a line, that from the axiom 2, as a ray stand on line, then CD form a lines that is the 180 degree. We can write AOD plus BOD. AOD plus BOD equal to 180 degree. Similarly, a ray OD stand on AB, so it will be also be a line. So from 1 and 2, we can see that from 1 and 2, AOC plus AOD equal to AOD plus BOD. You can see. So this implies AOC plus equal to BOD. That is, equal is subtracted from equal, then the remaining will be equal. That is axiom third one from the Euclid's axiom section 5.2. We have a study about the Euclid's axiom, that if equal is subtracted from the equal, then the remaining will be also equal. So AOC equal to BOD. So here you can see AOD equal to BOD. So vertically AOC equal to BOD. So we can say AOD is vertically opposite angle of BOD or BOC. So BOC is equal. So similarly, we have proved that we can other angle we can also prove by these methods. So thank you. Today class we have a study about the lines and angles, and the different type of lines and angles we have solved, as you can see here. And we have a study about the linear pair, axiom, theorem in these sections. So next class we will solve the problems related to the lines and angles. Thank you.